Good morning. Really excited to be here again. I think this is the year, Anand and Mark said, the year that I think confidential computing is going to be mainstream. Yes, Aaron, we need to get together. We've been talking about it for a while. We never get together. Today, I'm going to start with talking about something that happened. It happened last year. A company was testing an agent, and they were building an application. They had a code freeze in place and explicit instructions to not modify anything. The agent was in the live environment, had access, continued to do stuff, ended up deleting a commercial database. So the company, to be fair, they owned it. They put in the right safeguards, the right permissions. But really, this really highlights where the era that we're going into. These agents are no longer just generating code, answering questions. They're taking actions on our behalf. So that's a broader question. Really, the broader lesson is going to be, how are we going to protect against that? This is the agentic era. So if you think about how it evolved over time, we went from a place to just AI was answering rule-based, scripted systems, went to virtual assistants, then went into chatbots, then AI automating things with AI and tools. And today, we're in the autonomous agent era, where now the question is, what are we going to allow these agents to do for us? Because once they act, we need to follow the workflow and verify and attest that they're doing the right things at the right places. As agents become more autonomous, more steps, more tools, more coordination is happening. That's what makes them agentic. They're deciding and they're acting. A lot of this coordination is now shifting to the CPU again, because that's where a lot of these sensitive data and APIs are. So the more these workflows are shifting to the CPU, the more orchestration is happening, the more the attack surface is opening up. So if you think about what agentic means, that means these agents are going to need access to tools, credentials, sensitive data, APIs, actions, all really to create this business impact of new ways of doing things, which is exactly what technology is evolving to. So we need to follow that workflow. We need to attest the workflow. I'm going to highlight an example here to illustrate. It's in a financial industry example. A woman sends out a prompt and says, please rebalance my portfolio before earnings. This kicks off a series of agentic workflows. There's going to be an orchestrated agent that is now going to try to interface with her portfolio, that's going to go look at her portfolio. It's going to be a interface with a compliance agent, execution agent. That execution agent is going to have access to trading API. And all of these places, as you can see, there's multiple ways where we can have some security incident, whether it's injecting a prompt or it's really interfacing or having an agent that has extra permissions to do different things. All these things are really expanding the ability to have breaches. So what can we do about it? So this is really the rest of the talk is based on this. What we want to do, we want to make sure that we build an attestation gate, that we can actually attest these individual agents, not only to see who they are, but really to know, are they acting properly? Are they executing in the right environment? Have they been tampered with? And this is essentially what confidential compute does. So let's connect the dots. We're going to need an agent, has to have access, and we want to make sure that it verifies that it hasn't been tampered with, that it's valid, it has the right permissions. This is something that we need to verify, but how do you verify? We really can't trust software to verify that. We're going to need to root it in the hardware. The hardware is going to have to be the one that really gives us that assurance that hasn't been tampered with, and it's really running the way we want it to run. The good thing, this is not new. You know, AMD has been making confidential compute products since 2017, 5 generations of server CPUs, production at scale. And really, one of the big things that we do understand is confidential computing is not just our foundation, it's a whole ecosystem. Really, we're already production at scale with the major cloud providers. And one of the big things that we really believe is security. We don't want to see it as a black box. Security, we really understand that we need to be transparent. So we focus a lot on open standards, community work, because we feel that that's the way we're going to give more assurance to the world about confidential computing and the benefits of that. The beauty about the confidential computing hardware is that we have multiple ways of using it to protect your workflow. You could optimize your workflow. So here I'm going to share like 3 patterns. One pattern being taking each agent and putting them in an individual confidential VM. That gives you maximum isolation. You know, they get own key, own measurement, and it gives you the ability to contain any breach there. Second pattern could be you could create a virtual VM that has the orchestration, the control plane, and builds agents within there. Gives you a little bit more high density, lower overhead. And an emerging model that's coming up, it's a hybrid model where you have one orchestrator VM that kicks off ephemeral, you know, confidential VMs that get started and killed once they complete their task. On its own, confidential computing is really the foundation. But it's really, we see it as 3 layers, right? So the first one being the agents, the tools, the data, the APIs, the actions. And the middle layer is where our partners come in. Our partners provide the policy enforcement, supervision, evidence, auditability. And at the bottom, of course, is AMD's trust execution, isolation, and attestation. I want to zoom in the middle layer and talk about some examples of our partners. So I'll start with Ajuna. Ajuna's built their control plane is in a confidential compute environment, and from there, they're able to watch the different agents and test them to that within prompt injection, policy, integrity, or just auditability. Another approach is opaque. We heard Aaron talk about it, my drinking buddy in the future. But their approach is really that you set the rules and you get proof it actually was enforced. Every agent gets their own CVM, but then they go in there and create the ability to verify the agent before it starts, enforces the policies, and it creates an auditable record that you can hire a third party to audit what happened across the board. So not every agentic flow is going to be working in the cloud. Some of the needs are going to be different, and sometimes the data, the workflows have to be closer to the operations. One example could be low latency at the source, think manufacturing, edge AI inference, think telecom, and regular sovereign data that we've been talking about earlier today, that some of the stuff that has to happen in either healthcare or a nation state wants to protect a certain technology, and an operational continuity. Utility companies where you can't depend on having an internet connection. So when AI runs closer, you need to still verify and validate those workflows. And that's exactly what Azure Local comes in. Azure Local is as Mark mentioned, it's a way for us to to really connect these different type of environments in one way, whether it's public cloud, hybrid on-prem, or edge disconnected air-gap networks. The beautiful part about this is that it's the same foundation. SEV across the board, and you could still do the same kind of thing, but across the board in a hybrid environment where you have still secure provisioning, guest integrity, composite attestation, and policy-based key release. There's going to be another talk here in the Gold Ballroom at 1:15. I invite you guys to go in there and hear more about the details about Azure Local. So I want to finish the talk with 3 takeaways. One is, again, Agentic AI is changing the way we need to protect the data. We need to follow the workflow. 2, there's a proven foundation. SEV has a proven foundation to build to protect that workflow across the board from cloud to local. And the third is that our partners are already providing very good solutions to really take that governance and make it a reality. My last takeaway here is I want you to kind of think about the example of the woman who just sent 5 words in a prompt, and all the data flow in agentic that got manipulated and potentially exposed. Think about that. Think about that workflow is one workflow. In your organization, there's going to be many workflows already happening. The decision to be agentic is already done. So we're going to go agentic. It's already done. It's already in play. It's a decision is, are we going to verify in the trust model, or we're just going to assume that it's trusted? Thank you.